All right, guys. So hopefully you watched the videos I posted first so you can get like a conceptual, visual understanding of what it means to complete the square. Um, this I would have made my own video if I had those tiles, if I had more time. But hopefully those were helpful. And just seeing what it means to complete the square with our quadratic equation. How we're filling in those missing pieces, what we're doing with those extra pieces, um, visually what it means to have a perfect square, to be a perfect square. And we've gone over what are perfect squares, x squared, 36, 49, all those types of terms. So hopefully that gave you a little prior knowledge on the process. I'm going to show you here. I'm going to model a few problems, and then your homework assignment will just be to do like 4 problems on your own by like how I do it. Okay? So, first I'm just going to show you like in the beginning what we used to start with. So I'd give you like a trinomial. A trinomial has 3 terms. And I asked you to factor it. So you're saying to yourself, all right, what are 2 numbers that make 36 and what are 2 numbers that multiply to 12 so that we can positive 12 so we can factor by grouping and all that good stuff. So if you're realizing they're both the numbers are 6. So if we were to, group this or factor this out, we would get x plus 6 and x plus 6 as our 2 parentheses. But if you have 2 of them, we can make it into x plus 6 squared because we have 2 values. So this is called a perfect square trinomial because of the fact that we get the 6 both times. We get the 2 6s. 6 squared is 36. Half of 12 is 6. Okay, and that would, if we were to draw this out, we would get the perfect square. Let's try another one. So if we had x squared minus 12x plus 36, is this a perfect square trinomial? So let's say what 2 numbers multiply to 36 and add to a negative 12. Is there an answer? Well, negative 6 plus negative 6 is negative 12. Is negative 6 times negative 6 positive 36? Yes. So if we were to factor this, we would get x minus 6 and x minus 6. And since they are the same, right, we're basically multiplying by the same thing on the top and bottom, we get this whole perfect square. So yes, this is a perfect square trinomial. Okay. Negative 6 squared is 36. Half of negative 12 is negative 6. So it works. So the pattern here is if you take this middle term, this linear term, so the pattern is if you take this middle term and you half it or divide it by 2, that's going to be the number that is inside of your perfect square trinomial when you factor in the factored form. Okay, and if you did this out, it would work. So if we try this with a different one, so now we have x squared plus 20x plus 100. Is this a perfect squared trinomial? It is. So all you have to do is take half of this term, which is 10, and that will be the number that you use in your factored form. Right? Even if we check ourselves, what 2 numbers make 100 and what 2 numbers add to 20? The answer is 10. They both are 10. So, right, and if we square this number, we do get 100. So this is a perfect square trinomial. And the factored form is x plus 10 squared. Okay. So that was just a little practice with factoring and how it connects with the process of completing the square because we're trying to get this perfect square trinomial. So now let's go over one which is now like what your homework's going to be like when it's not a perfect square. We have to complete the square now. So here's your first problem on what your homework's going to look like. So now we're actually we need to complete the square. Why do we need to complete the square? Well, are there two numbers that multiply to 3 and add to 8? What two numbers multiply to 3? Just 3 and 1. Does 3 and 1 work to equal 8? No. So we know that it's not a perfect square trinomial. Also, if we halved if we halved 8, sorry, and we get 4, 4 squared is 16. So this number should be 16, but it's not. So now what we're going to do is we're going to complete this problem. So the way to complete the square is what I just did. You take this middle term, you take the linear term, and you halve it. So half the linear term. Remember, the linear term is the term with a number and x. The second step is you square it, and I'll put these steps online, but I'm just showing you what I'm doing. Step 2 is I squared it, so I squared this 4 to get 16. So now what I'm going to do with this 16 is I'm going to add it to my quadratic because I want to complete this. I want to make it a perfect square trinomial. So what I'm going to do with the 16 is now rewrite it into my problem. So I'm going to have x squared plus 8x plus blank plus 3 plus blank. And I'm kind of setting this up for you so you have like a step-by-step. So now my third step is I'm going to add that 16 into my problem. So before I took my linear term, I halved it, I divided by 2, I got 4. I squared it. So now I'm going to take this 16, I'm going to do step 3. I'm going to add it to my trinomial to make my perfect trinomial. This is a perfect square trinomial. But if I'm adding it to the 16, think about it. I can't just add a number to an expression. So what can I put in this blank to mathematically make this expression viable or true? Like, I can't just add a number. So if I'm adding a 16 here, what should I add here? Careful, we don't have an equal sign. So it's not like you're going to add a positive 16 because then I'll have positive 32. I don't want to add a positive 16. I want to add a negative 16. Think about it. If I'm adding a 16 here in the same expression and I want to make it like so that I'm actually not adding anything, I'm actually going to add a negative 16 because what's a positive 16 plus a negative 16? 0. So this is why the two signs have to be different. Because you can't just add a number to an expression. That doesn't make sense, right? You're going to change the whole thing. So we're going to add a 16 to the middle and then add the opposite to the end of the expression. Okay? Hopefully you're still with me. We're going to do a few. So now we have our perfect square trinomial on our left. We're going to factor this. So if we go back to our term, what was the term that should be our factor number? It should be 4. So x plus 4 squared. And then we simplify this to minus 13. And that's your answer. Okay? Let's do another one. All right, so our next one, we have a squared. I'll use x so you guys don't get weird with the variables. X squared minus 4a plus 15. Okay, we're completing the square because this isn't a perfect square trinomial. No two numbers multiplied make 15. That will also add to negative 4. Right? We only have like 5 and 3, 15 and 1. It won't work. So we need to complete this square. It is not completed. If we made it visually, which I can show you. So we take this first we take this term of -4, we have it, divided by 2, have it, then square it, and we get a +4. So now we take our original and we have to add in that value that we get, and also add it on the left, on the right. So we get, so this 4 is going to go +4 here, but since I'm adding the 4, I need to subtract it on the right. Right, you're always doing the opposite. If this was a -4, you'd put the -4 here, but since it's a +4, you're putting the +4 here. All right, and then we factor, and remember this number is how we factor it. So it turns into x minus 2 squared. And then simplify this on the right, plus 11. And that's my answer. So there is a pattern, right? And you kind of don't have, this step is optional. Because you can like reference this top equation if you need to, but writing this out, this step out, is important just to know where those terms go and like what's happening with them, right? You're allowed to factor this because we're factoring by grouping. We're putting these 3 terms together to factor them by to factor them into that perfect square, because it's a perfect square trinomial. So we're allowed to actually break those up, right? It's addition. You're allowed to use the commutative property, associative property, group things together that you can, and work with those first. So if you're thinking to yourself, why can we just, why aren't we adding 4 plus 15 minus 4? Why aren't we doing, we don't want to get back to our original problem. We're trying again to break this down to, add that missing piece in to complete that square. So that is that one, and I'll do one more. So I have x squared minus 2x minus 15. Okay, right, I'm telling you to complete the square. This is not a perfect square. Again, 2 numbers that make -15 and add to -2 just don't exist. If we did use 5 and 3, let's see. Actually, this does work. Yeah, so this does work, right? This does factor, so this is a good example. My bad, I was looking at a different one. So this is factorable, but why do I not want this? Like if I factored this, this is what I would get. Why do I not, why do we still have to complete the square is my point here. So if you're looking at this, you're saying, Miss Almedico, there are 2 numbers that work, it's factorable. Why do we need to complete the square? Well, the point of completing the square is to make a perfect square trinomial. So my question to you is 15 a perfect square? Is 2x a perfect square? Do we have a perfect square? No. So the fact of the matter is that the square isn't completed. So we do need to still complete it, even though it is factorable. Okay, so that was good that we looked at that. So again, this is factorable, but we need to complete the square because these are not perfect squares. These numbers need to be the same. Since they're not the same and there's no way we could get them the same, the square is not, we need to complete the square process. Okay? And always complete the square even if you think, like, if that's the instructions, that's what we're going to do. So again, we're going to take this middle term. We're going to half it. and then we're going to square it, and we're going to get positive 1. And I'm putting that positive 1 just to remind myself I'm adding the 1 to the trinomial. So what I'm going to do here, I'll just rewrite the original so we remember. We're going to add that term here and then do the opposite over here. So I'm going to add my 1, and that means I'm going to subtract it over here, right? Because we want the 0. We don't want to be adding just a random number. Okay, factor by grouping. Remember, this factors into this term. So this term right here is basically the factored number that goes in. You can do it yourself if you want to check, but that's how we're substituting. It goes quicker. And then we simplify this to minus 16, and that is your answer. Okay. Again, I wish we were in the classroom so I can show you visually. I wish we could all work with the algebra tiles that are presented in the video. It's a better way to actually like see it and explain it for my learners who like to see the visual. Hopefully the video I showed you will be useful. If we get back to the classroom, I can break those out. We can make them, or I can order them. But hopefully this process was okay for you to follow. I will post steps, and I will have problems to do, and I'll post those